Hi everyone. In today's video, we will walk through the process of installing multiple Istio control plane in a single cluster, and we will find a way to scope workloads for these specific control planes. And we will verify the installation via deploying some sample workloads into the cluster. Next up, this is the architecture we will have for installing the multiple control plane in a single Kubernetes cluster. So we have one single cluster, as you can see here, and we will be creating two different namespaces. So the isolation will achieved using the namespaces. So we have one namespace user group 1, we will have another namespace called user group 2, and we will install Istio control plane in both the namespaces, and we will install sample workloads, and we will manage these workloads using the independent individual control planes. So this is our architecture will look like. Now let's go ahead and see the process of installing this setup. So for deploying a multiple control plane on a single cluster, we will first start by creating a cluster in our Kubernetes. So I'll be using kind. If you are using Minikube or any other, you can use that. So let's start with creating a cluster first. Kind create cluster name is equal to cluster. I'll be naming it as cluster. So this will create a kind cluster in my local laptop. So let's give it a moment for the cluster setup to be done. Okay, so now our kind cluster is created. We can see in Docker desktop also here we have one cluster running, and once we have the cluster ready, we can start setting up the multiple Istio control plane on a single cluster. So to do that, we can achieve that by installing these control planes on different system namespaces. For each control plane, we will have a different namespace and Istio revisions and discovery selectors. So we'll use Istio revisions and discovery selectors to scope the resources and workload that will be managed by these individual clusters. Let's first create these namespaces. So kubectl create namespace user group 1. So this is our first namespace, and let's create another namespace user group 2. So now we have two namespaces. In this we will install the Istio control plane. We need to label this with the user group. Let's label the first namespace user group 1. Now let's do the same for namespace user group 2. And now we have the namespaces labeled, and we can proceed with installing the Istio control plane. So I have a istio values.yml file. Here we will see the content of the file. So here you can see the namespace is user group 1, revision we have set as user group 1, and discovery selectors user group match labels user group is user group 1, and we have set Istio global Istio namespace as user group 1. So the revisions and discovery selectors are used to scope the resources and workload for this particular control plane. Also by default, Istio will scope workload endpoint using discovery selector. If we want to enable full resource scoping, including configuration resources, we need to set the enable enhanced resource scoping as true. So with this configuration, we will install Istio control plane. So here I have I'm using istioctl. So istioctl install, and I'm passing this file, and this will install the first Istio control plane in user group 1 namespace. Let's give it a moment for control plane to install, and then we will follow the same approach to install the Istio control plane in our second namespace, which is user group 2. Let's just give it a moment. this should be done. Yeah, now it is done. Let's see the content of for our second control plane. So here is the file. Here namespace is user group 2, revision is user group 2, discovery selector match label user group 2. This is we are doing for our second control plane, and enable enhanced resource scoping is true for this as well. With this, now let's install second control plane in user group 2 namespace. So once this is installed, we have two namespaces in single cluster, and Istio control plane is installed in these different system namespaces. Cool. So now we have control plane installed. Let's see if we have it running. So in first namespace, kubectl get pods user group 1, we have istiod running, and in user group 2 also we have istiod running. That means the installation is successful. Now what we want here is that the workloads in user group 1 and user group 2, they will accept the MTLS traffic. So for that we will deploy a policy for that. Let's see that policy file content. So this is for our first namespace user group 1 and first control plane. Here the kind is peer authentication. It's applying on namespace user group 1, and the MTLS mode is set to strict. So this will make sure that we only accept MTLS traffic. Let's apply this policy to our first control plane, and then we'll do the same for our second control plane. And it's done. Now we have two control planes running on two different system namespace under single cluster. Now to verify this, let's install some sample application that we will use to communicate within this cluster and verify that we have two different control planes and they are running as expected. Okay, so let's start by creating namespaces. So even these sample services are running into their own namespaces. kubectl create namespace app namespace 1. So this is my first namespace. Let's create another for app namespace 2. So now we have two namespaces for our sample apps. Let's label them. So these labels are user group 1 and istio.io revision user group 1. So this will make sure that we have sample apps scoped out properly. And for user group 2, label namespace 2 user group 2 and istio.io.revision is user group 2. So now once we have namespaces labeled, I'll be deploying a sleep.yml file, which is like basically we are deploying a sleep app, and HTTP bin. We will use sleep to call HTTP bin and verify that communication is happening. So I have deployed on app namespace 1. Let's deploy on app namespace 2. So sleep is deployed, and let's deploy the HTTP bin. So now with this setup, let's revisit what we have done. We created one single cluster and we deployed two Istio control plane into different namespaces, and then we deployed sample apps into different namespaces. And user group 1 is the workload in user group 1 are in app namespace 1. So the one Istio control plane which is in user group 1 is only managing the app namespace 1 applications, and user group 2 control plane is only managing the app namespace 2 services. Now let's see if the apps are running. So kubectl get pods -n app namespace 1. It's still initializing. Let's give it a moment. Let's check in app namespace 2. Here also it's still taking time to come up. App namespace 1 is ready. Let's take app namespace 2. Okay, both the services are up and running. Okay, now that we have application deployed, we can use istio-ctl ps command to confirm that the application workloads are managed by their respective control plane. What I mean by that is that app namespace 1 is managed by user group 1 and app namespace 2 is managed by user group 2. So for that, let's run the istio-ctl ps command. And for user group 1, we can see the http bin and sleep app which are in app namespace 1. So that is correct. And let's check for user group 2. Here for user group 2, we can see that http bin and sleep app is in app namespace 2. So these are properly scoped out. Now let's check the communication. So what we will be doing to test this is that we will be calling from sleep pod in app namespace 1 in user group 1 to the http bin service in app namespace 2 in user group 2, and that should give us a 503 error. Let's check it out. So here is the command. Basically what we are doing here is let me format it. So from here we are doing an exec to sleep pod in app namespace 1, and from sleep pod we are calling the http bin in app namespace 2, and our expectation is that this call should not get through because we cannot we have isolated the control plane and the services in app namespace 1 in app namespace 2. So from app namespace 1 we should not be able to reach to app namespace 2. Let's see, and yeah, 503 as expected. Now to verify further, what we need to do is let's call from sleep pod in app namespace 1, and we'll make a call to http bin in app namespace 1 only. Let's see that. Here we are calling from sleep pod app namespace 1 to http bin app namespace 1, and this should result in a success response. And yes, we can see here 200 okay. So things are working as expected. So things are working as expected. Next step, we need to clean up. So to clean that up, let's uninstall istio-ctl uninstall revision user group 1. Then we need to do the same for user group 2. So it is done. Now let's delete the namespaces that we created, app namespace 1 and user group 1. And then we will delete the app namespace 2 and user group 2. And finally we will delete the kind cluster that we created. So let's wait for namespaces to be deleted and then we can delete the kind cluster. It's done. And finally delete the cluster, kind delete cluster, and our cluster is getting deleted. Here we can see that cluster is deleted and our cleanup is done. And with this demonstration we achieved installing multiple control plane in single cluster and properly scope the workloads for those cluster. Thank you for watching.